Hi everyone, I'm Jackie, TA from the Tuesday at 7 p.m. class. This is Spring Week 5, Level 3, Problem 5. So before we get to it, let's start by reading it if you haven't already. It says, in the figure shown, AB is a diameter of circle O. If AC equals 6 and the radius of the circle is 5, what is the perimeter of the highlighted regions? In this diagram, of course, they're crossed off, but that's the region it's talking about. So let's go over what the problem just told us. We know that AC equals 6, so let's find AC on the diagram. This is point A, and this is point C. So this line here must be AC, must be 6. Now obviously we're not given units in this problem, so it's 6 units. R, which is the radius, equals 5. Recall that the radius of a circle is the distance from any point on its outside to the center. So OA or OB could be the radius, and both can be labeled as 5 units. And then AB is a diameter of circle O, so AB here goes all the way across straight through the center, and that's going to be important later when we get to the perimeter. Alright, so let's start by going and seeing what the perimeter is that we have to measure. So I see that this is one part of the perimeter here, and then we have a curved section, and then we have this leg here. We already know that this part is 6, so what we need to find is the curved portion and this piece. Since this is a right triangle, I know that I can find this piece using the Pythagorean theorem. But what does that mean? Pythagorean theorem, if you recall, is written as a squared plus b squared equals c squared, where a and b are legs of the right triangle, the pieces that attach to make a right angle, and c is the hypotenuse, which is the longest part of the triangle. In our triangle, our hypotenuse is also the diameter, AB, and its length is 10, because 5 plus 5 is 10. Alright, in this diagram, we're lucky because point A is across, this can be written as side A. Point B would be across from what can be written as side B, and point C is across from the hypotenuse. Of course, in any other diagram, you get X, Y, Z, but always remember that C squared, or whatever letter you have, represents the hypotenuse. Alright, let's plug in what we know. So I know that C would be 10 squared, and I'm going to say that B is 6, because that's what we have written in the diagram. And then we do not know A. So we want to isolate the variable A. Let's start by taking this as plus 36, because 6 squared is 36, is equal to 100. Then I subtract 36 from both sides, because it's an equation. Whatever you do to one side, you have to do to the other. And I end up, cross these out, 100 minus 36 is 64. And then I have to take the square root of both sides, because A is squared. A equals, now because it is a square root, you can write plus or minus 8, but since it's a whole number value that represents the length of a side, it obviously can't be a negative length, so I know that A is 8. Now I have 2 parts of my perimeter that I know, and I just have to find this third curved piece. Now what do we know about it? We know that the points bounding the curved piece, A and B, are a part of the diameter. And a diameter can split the circle into 2 equal portions. So this curved piece is 1/2 of the distance around the circle, also known as the circumference. If you've ever heard of the circumference, it's written like this. Circumference equals pi times diameter, or 2 times pi times the radius. So we know that the diameter is 10, or the radius is 5. I'm going to use 2 pi r. Circumference equals 2 pi, also known as 3.1415, and so on. And then plug in for r equals 5. The total circumference around the circle is 10, but since I only want half, I can divide that by 2. 1/2 of the circumference is equal to 5 pi. And so now I have my perimeter being the 5 pi portion here, plus 6, plus 8, so perimeter, P, equals 5 pi plus 6 plus 8 which equals 5 ply plus 14. And that's our answer.